Hello everybody, welcome into another lesson. Today we are going to talk about proportions. Well, you may be wondering, what are proportions? They are simply two ratios set equal to each other. But in order for something to be a proportion, both ratios have to be equal. So for example, let's say we have the ratio of 1 to 2, we set it equal to 2 to 4, right? We could set that equal to 2 to 4. Well, of course, 1 to 2 is 1 half. 2 to 4, is that equal to 1 half? Well, yes, because if you have a common factor of 2 between the 2 and 4, you divide 2 by 2, you get 1. You divide 4 by 2, you get 2. So, yeah, 1 half would equal 2 fourths, because you'd have 1 half equals 1 half. So, therefore, yes, this is proportional. This is a proportional relationship. Now, what if I set it equal to something like 3/7? Well, 3/7 is clearly not 1 half. 3 and 7 don't reduce any further, so it can't reduce to 1 half. Clearly this isn't true, so this is definitely not a proportion because the left side doesn't equal the right side. It's not a proportion. So yeah, in order for it to be a proportion, the left side has to be equal to the right. So that's pretty simply what the definition of a proportion is. Alright, let's set up a couple tables here. I'm going to set up a couple tables here, okay? Let's see, we got blue paint to yellow paint. This is a proportion, this is not a proportion rather, this is supposed to be a table of blue paint to yellow paint. So you got 1 blue paint to 5 yellow paint, 2 blue paint to 6 yellow paint, 3 yellow paint to 3 blue paint to 7 yellow paint, and then 4 blue paint to 8 yellow paint. Okay? So in order to determine something like this, you have a ratio of blue paint to yellow paint. You got 1 part of blue paint to 5 parts yellow paint, 2 parts of blue paint to 6 parts yellow paint, 3 parts of blue paint to 7 parts yellow paint, 4 parts of blue paint to 8 parts blue paint. 8 parts yellow paint rather. So if you want to determine if it's in proportion, take your first one, your ratio of blue paint to yellow paint. You got 1 to 5, right? Now pick the next one. Go ahead and pick your next one. Is that equal to 2 to 6? Well, does 2 over 6 reduce to 1/5? Let's find out. Of course, you got 1/5 on the left. 2 over 6. Well, 2 and 6 both have a common factor of 2. 2 divided by 2 is 1. 6 divided by 2 is 3. That'd be like saying 1/5 equals 1/3, which we know isn't true. So we don't have to plug in any other values. This is not proportional. So this is not a proportional relationship because you don't get the same ratios for each ratio of blue paint to yellow paint. So no, this is clearly not a proportion. Clearly not. Try to keep the table format here because it's going to come into handy for it will come in handy for the next few problems we're going to do. Alright. What's the next one here? Alright, so we have the ratio of iced tea mix. We have iced tea mix to sugar. Sounds like someone's going to be making some iced tea. That sounds pretty good. So you have iced tea mixed to sugar. So you have a proportion of 1 part iced tea mix to 2 parts sugar. 2 parts iced tea mix to 4 parts sugar. 3 parts iced tea mix to 6 parts sugar. And 4 parts iced tea mix to 8 parts sugar. Is this a proportional relationship? Well, again, start with your first ratio, the 1 to 2. You have 1 to 2, so 1 part iced tea mix to 2 parts sugar. Is that equal to, let's pick the second one. Is that equal to 2 parts iced tea mix to 4 parts sugar? Well, it turns out 2/4 does reduce. You'll have 1/2 on the left. On the right, you'll have 2/4, which we know reduces to 1/2. So far, they match. So far, it's a proportion. So far, indeed, we have a proportional relationship. But we want to test all of them. Does 1/2 equal 3 parts iced tea mix to 6 parts sugar? Well, you'll have 1/2 on the left. Now 3/6, you have a common 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 1/2 equals 1/2. Yes, so far it still checks out. Last but not least, set your first ratio equal to the last one then for the final check. Is 1 part iced tea mix to 2 parts sugar equal to 4 parts iced tea mix to 8 parts sugar? Well, you'll have 1/2 as your first ratio. Now 4 and 8, they have a common 4 that factors out. 4 divided by 4 is 1. 8 divided by 4 is 2. And 1/2 does in fact equal 1/2. It's checked out for all of these, so your answer is yes. This is a proportional relationship. This relationship is in fact proportional. So, as long as the ratios equal, you got a proportion. If they don't equal, you don't have a proportion. It's really that simple. Just bear with me a minute here while I erase some of these. We're going to go ahead and erase them. Okay. What's the next one? Let's see. We're making some juice apparently. It's concentrate to water. We got cans of concentrate to cans of water. So the concentrate to water, so it's 1 part concentrate to 4 parts water, 2 parts concentrate to 8 parts water, 3 parts concentrate to 12 parts water, and 4 parts concentrate to 16 parts water. Okay? So it looks like you want to start with your very founding ratio of 1 part concentrate to 4 parts water. Now, take your second one. Is that going to be equal to 2 parts concentrate to 8 parts water? Well, let's find out. Of course, we have 1/4 on the left. 2/8 actually does reduce. 2 and 8 both have a common 2 between them. You divide 2 by 2, you get 1. Divide 8 by 2, well, you're going to get 4. So far, it checks out. So far. But if even one of these fail, if even one of these in the table fail, you don't have a proportional relationship. It's got to be all of them. So does 1 part concentrate to 4 parts water, is that equal to 3 parts concentrate to 12 parts water? Well, 3/12 actually does reduce. You'll still have 1/4. Now, 3 and 12 have a common 3. You divide 3 by 3, you get 1. Divide 12 by 3, you get 4. So far, again, it checks out. The final test is going to be the 4 parts concentrate to 16 parts water. Is that equal? Do they equal? Well, of course, you have 1/4 on the left. 4/16 reduces. They both have a common 4. 4 divided by 4 is 1. 16 divided by 4 is 4. So yes, 1/4 equals 1/4 on all of them. It checks. The relationship is in fact proportional. So we have a proportional relationship here, since the ratios have been the same. I'd like to do at least one more. This will probably be a short lesson today, because understanding proportions honestly is easy enough. Yeah, if you try to understand proportions, it's actually quite easy. The ratio on the left side has to equal the ratio on the right side. If it doesn't, then you don't have a proportion. It's really that simple. All you have then is a false statement. All right. Let's see. We're going to have a ratio of shaded squares. So shaded squares to total squares. So let's see, it starts with 1 shaded square to 8 total squares, 2 shaded squares to 15 total squares, 3 shaded squares to 30 total squares, and then 4 shaded squares to 42 total squares. So what you got to do again, take your founding ratio, the 1/8, the 1 shaded square to 8 total squares. Let's pick on your second ratio here, the 2 shaded squares to 15 total squares. Does 1/8 equal 2/15? First ask yourself, does 2/15 reduce any further? There's no common factor between 2 and 15, so the two ratios are not equal. Therefore, right away, we don't have to go any further. We can clearly tell this is not a proportional relationship. This is not proportional, because the ratios don't all match. So basically, it just comes down to proportions. The ratio on the left side has to equal the ratio on the right side. If they don't equal, all you have is a false statement and not a proportion. So that's really all there is to understanding proportions. Now, next lesson, we're going to do a little bit of algebra with some proportions. We're going to find values for variables that would make the statement true to make it a proportion. So stay tuned for that. I hope everyone has a good night. Take care.